Okay, so going into the last technique, so this is integration by partial fractions. So I don't know if you have partial fractions as a topic in your algebra, but way back before, since we have advanced algebra in our curriculum, so we have discussed partial fractions in that particular subject. And upon reaching integral calculus, so we just have to review this topic and then we're able to immediately go to the different integrals. Okay, so for some of you who don't know how to solve partial fractions, so just follow along as we go to the process of integration. So most likely we are going to solve it using partial fractions first before integrating. So the long process is more on the partial fractions and then less of the integration process. Okay, so observing the column in the left or in the first column, so that's the factor in the denominator. So factor in the denominator meaning the form of the factors in the denominator or the terms found in the denominator are in the form of these four. Okay. So for example, you have the first line here, ax plus b, or let's say you have a binomial, or let's say you have a a single algebraic expression. So the particular partial fraction decomposition is a over ax plus b. So if you don't know this topic, so there's a purpose why this is the particular partial fraction decomposition. Okay, and then we have ax plus b to the power of n. So meaning the first term, the first line, if you compare it with the second line, so it's just raised to the power of n. So if it's raised to the power of n, so you have ax plus b, and then you repeat it until you reach that certain degree of power or exponent. So let's say cube or to the fifth degree. Okay. So the first one is what we call as your distinct linear. So that's what we call the first term, distinct linear factor. And then the second one, since it's the same as the one above, so instead of it's distinct, so we'll call it as repeated linear factor because it's raised to the power of n. Okay, so for the third and the fourth one, so as you can see, the third one is ax squared plus bx plus c. And it gives us this particular partial fraction decomposition, ax plus b all over the factor in the denominator, which is ax squared plus bx plus c. So this one is called as distinct. So notice that since this one is squared, so this is distinct quadratic factor. And the last one, since it's just repeating from the third one, so that's what we call as repeated quadratic factor. So I don't think that we can reach your fourth line because if we have to if we're going to solve repeated quadratic factors, so we're going to reach up until probably 4 or more unknowns in your equation. So how do we apply these partial fractions? So again, if you don't know how to solve partial fractions, so might as well review them. But I can assure you that most likely one problem will come out from this topic. So only one. So as far as my experience can tell. So usually it's a difficult problem because most of the kind of new curriculum students don't know how to solve partial fractions. Okay, so we're going to solve 3. So cunning 4 is, since it's repeated quadratic in the fourth one, so I think it will take up so much time, and we'll be going to have 5 unknowns, and I don't know if you know how to solve 5 unknowns since you don't know, since you don't have advanced algebra. So if you have advanced algebra, so you can solve 5 unknowns using matrix. But since you don't know, I think you don't know how to use matrix, so that's why up until 3 lang ta. So let's try solving 3 problems. But if you want to try to solve number 4, so I think you'll be stuck in the process of solving 5 unknowns. Okay, so before we proceed to number 1, so how can we know that we're going to use partial fractions? So upon observation of the equations, so you can only use integration by partial fractions if the degree in the numerator is lesser than the degree in the denominator. So what do you mean by degree? So that's the highest power in the term in the numerator, and then the highest power in the term in the denominator. So if you try to observe the numerator in number 1, so 2x to the power of 1, excuse me. And then in the denominator, the highest degree here is squared. So that's first degree against second degree. So notice that the numerator is lesser than the denominator. So we can use partial fractions here. Here is we have 3 in the numerator in number 2. In the denominator, so you have 1 here plus 3, so that will be 4th degree. So third against 4th degree. So that's how we know that we can use partial fractions. So number 3 here, so numerator, the highest degree here is to the power of 2, second degree. Then denominator is 3rd degree, highest exponent. So notice second against third, so again we can use partial fractions. So also for number 4, so that's the 3rd degree. And then if you try to observe the denominator, so to the power of 1, because you still have to multiply them individually, but if you have to expand it, then this one, upon expanding, this one is to the power of 4. So this one is a 5th degree. Okay, so that's how we know how that we can use partial fractions. So how about if your numerator and your denominator is equal of degree, or the numerator is bigger than the denominator? So for example, you're going to have this one, x all over x minus 1. So notice that you have equal degrees, equal powers. So you can use long division. Diba? So especially for those equations having bigger exponents, so let's say x cubed minus 1 divided by x squared. So numerator is bigger than the denominator, so you can still use long division. So partial fractions can be used if the numerator is of lesser degree than the denominator. So that's how you know when you can use partial fractions. So of course, if it's not lesser than the denominator, if your numerator is not lesser than the denominator, so you can use long division. So the purpose of using partial fractions is, so I think it's the same as your long division. So you can simplify further your equation. So of course this one will be simplified into terms of a over blah 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 plus b plus c. So depending on the number of unknowns that you're going to have. So again, the purpose of your partial fraction technique is for you to simplify these equations into a simpler version. So I think that's the aim of almost every advanced technique. So it's for you to create a simplified version of the original equation so that you won't have a hard time solving the integrals. Okay, so I think we can start with number 1. So in number 1, we have the integral of 2x plus 11 all over x squared plus 5x plus 6. Okay, so again, what we need to do first is we need to observe the denominator. So since we know that we are going to use partial fractions prior to this slide, so what we need to do next is, of course, we're going to observe the denominator. So since that one is x squared plus 5x plus 6, and since we're going to have factors, so we will try to factor this one out. So I think you know how to factor this one. It's purely algebra. Factoring algebraic terms. So this one is 3x, x plus 3, then x plus 2. Okay, so that's the first step. You need to factor out. Okay, so let's try to write it down. So factor. So next step is to identify your partial fraction. So this one is a distinct linear factor because this one is not repeating, because you have another distinct linear factor here, which is x plus 2. So two distinct linear factors. So distinct linear factor. So ako lang acronym. So distinct linear factor. So that's the next step. So you need to identify what type of factors that you're going to have. So meaning this one is, according to the formula, you're going to have a all over ax plus b, which is the term here. So that will be x plus 3. Then since you have another distinct linear factor, so it cannot be that you're going to have a again, but you're going to go to the next variable, which is b. So this is x plus 2 here. Okay, so that's how you start off with the partial fraction process. Okay, so far so good. So since I think number 1 is super clear, you need to factor out your expression given in the denominator so that we can determine what particular factors that we're going to have. Then second is we identify the factors. So we have a distinct linear factor. We have two distinct linear factors. So we have these terms here, a over x plus 3 and then b all over x plus 2. So what's next? So next is we ignore first the integral because we need to solve the partial fraction first. So what you need to do next, so number 3, is to solve the partial fraction. Solve the partial fraction. Okay, so again, we try to ignore first the integral symbol. So we need to write the equation first. So we're going to have 2x plus 11 all over x squared plus 5x plus 6. Okay, that's on the left side. And then on the right side is your corresponding partial fraction. So that will be a all over x plus 3 then plus b all over x plus 2. So usually this is how we solve partial fractions in advanced algebra. Okay, so next step is, since we have this form or we have this format, so we're going to multiply everything with the denominator on the left side for us to eliminate the fraction. So the purpose of eliminating the fraction, because we're going to solve the a and b constants. Okay, so multiplying by x squared plus 5x plus 6. So multiplying every term by x squared plus 5x plus 6 is we're going to have 2x plus 11 is equal to a. So a times x plus 2. So x plus 2 lang siya because again, in factor terms, this is x plus 3, x plus 2. Okay. Then plus b. Then this one is x plus 3. Okay. So that's how you create your single line, or that's how you eliminate the fraction. So next step is we're going to have two methods of solving a and b. So I'm going to show you the pros and cons of the two methods. So usually partial fractions is really a long topic. That's why it was introduced to us in advanced algebra. So I don't know if you have partial fractions in your senior high. Okay, so let's start off with the first method. So I'm going to call this 3.1 lang ana. So the first method is by elimination. So the pros of this is you can solve one factor immediately, but the downside of this particular process is that it's only applicable to two unknowns. So it could be three, but depending on the situation, but most likely it's only applicable in most cases for two unknowns. So since we have two unknowns here, a and b, so we can use elimination method. So what do you mean by elimination is that we let x be a value of something so that we can eliminate one variable. So let's say if you want to eliminate a, so let x be equal to -2. So this gives us 0. Or if you want to eliminate b, so let x be equal to -3 so that we can solve the a parameter. So let's say we want to eliminate b first because we want to solve a. So at x is equal to -3, again we want to eliminate b. So you want our x be equal to -3. Okay. So at x is equal to -3, so our equation becomes 2. So again, substitute -3 to every x in the equation. So 2 times -3 plus 11 is equal to a times -3 plus 2. So if we want to really put b here, so that's -3 plus 3. So this one is 0, right? -3 plus 3 is 0. 0 times b is 0. So what's left in the equation is we have -6 plus 11 is equal to a times -1. So we have 5 here is equal to -a. So our a value is equal to -5. So now we have the first value of the unknown, which is a equals -5. So the other method is, before we go into the other method, napaday B day. So if you want to solve B now, so we need to eliminate A. So at A, so to eliminate A, so the value of x must be negative 2. So negative 2. So again, replacing negative 2 to every x parameter in the equation. So that will be 2 times negative 2 plus 11 is equal to A times negative 2 plus 2 plus B times negative 2 plus 3. So we have negative 4 plus 11. Okay. And then again, this becomes 0. So the only term left here is B and then times 1. Okay. So we have 7 is equal to B, or B is equal to 7. So we now have A and then B terms here. Okay. So the other method is, let's go to the next slide. So the other method, so let's use another color. So this is 3.2, is by equating coefficients. So this is efficient because you can use this one to solve many unknowns, but it is a long process, but at least your answer is very sure. So by equating coefficients. Okay. So again, from the previous slide, so we have 2x plus 11 is equal to A times x plus 2 and then plus B times x plus 3. So the steps in equating coefficients is from the equation. So we need to expand this one further. So this one becomes ax plus 2a. So again, we expanded it. So we also expand b as well. So plus bx plus 3b. So next is we're going to group together the similar terms. So notice that we have ax and bx. So grouping them together, ax plus bx plus 2a plus 3b. So notice that that on the left side, so we have a 2x term here. We have a constant term here. So we need to make our right side be the same as the left side because we need to equate the coefficients of the terms. So what do I mean by that is, instead of ax plus bx, so we're going to have it as a plus b times x. Because we have 2 here as the coefficient of x, then the coefficient on our x on the right side is a plus b term. Then we group together also the constants. So 2a plus 3b. Okay, so we can now equate coefficients. So starting off with the x parameter. So that you won't get confused, so try to write x first. And then semicolon. Then writing the the coefficient of x on the left side, that's 2, is equal to, then the coefficient of x on the right side, that's a plus b. Okay, and then next one is our constant term. So let's write c here. Then the left side is 11. Constant is 11. The right side is 2a plus 3b. So we have one equation here and another equation here. Okay, so by algebra, so you can use two methods in solving two unknowns. So two unknowns, two equations, so you can solve by elimination or by substitution. So let's try to use elimination so you can directly solve A and B. So let's try eliminating B first. So multiply by -3. Okay, so this becomes -6. This becomes -3. This becomes -3b. So adding them up, so this one is 0. Then this one is -a. Then this one is 5. So you have a is equal to -5. So I think this one is the same as the previous slide. So I think you know how to solve two unknowns with two equations. So this time is we're going to use equation 1. So use equation 1. So we have 2 is equal to a plus b. And then we know that a is equal to -5 plus b. So we have 2 plus 5. So transposing 5 on the other side. So b is equal to 7. So I think we have the same answer as the first method. So -5 and 7. So -5 and 7 for the first method. Then -5 and 7 for the other method. So looking at your techniques, so I think the pros of elimination is since it's two variables, so it's very efficient. And then equating coefficients is also good, but it's a long process because you need to group together similar terms and then equating them to the coefficients on the left side. But again, the pros of this is you can solve up until two or more unknowns for equating coefficients. Okay, so since we know that the value of your a and b is -5 and 7 respectively, so we can now go to the integral. So equal then integral of, instead of that long fraction, so we're going to have -5 all over x plus 3 plus 7 all over x plus 2 dx. So notice that the given in number 1 is now transformed into this partial fraction. So that's the purpose of using partial fractions, to create an equivalent simple equation that's easy to integrate. Okay, so if you want to rearrange this one in such a manner that the negative sign is on the right side, so you can do so. So you have 7 all over x plus 2, and then minus 5 all over x plus 3 dx. Okay. So integrating is, of course, if you know that the integral of these two terms are ln, so you can answer it right away as 7 ln x plus 2. But if you're having doubts about the ln answer, so you can always verify it. So let's say this one is u. Let u be equal to x plus 2. Then du is equal to dx. So the first integral becomes 7 integral of du over u. Diba? So that's still ln. So on the right side, so let u is equal to x plus 3. Then du is equal to dx still. So this integral becomes minus 5, the integral of du all over u. So which gives us all ln. Okay, so the final answer for this one is 7 ln of x plus 2 minus 5 ln of x plus 3 plus c. So that's the final answer for number 1. Okay, so questions or clarifications? So I think what I explained so far is super clear. So if you miss something or if you don't understand something, so you can always try to go back to the recording. Okay, so if there's no question, so let's try to proceed to number 2. Okay, so this time we're going to have the integral of x cubed minus 1 all over x times x plus 1 cubed. Okay, so again, the first step is to factor out. So again, I'm going to write number 1 here. So we're going to factor this one out. So since this one is, I think it's already factored out. So muna na siya, di ba? X times x plus 1 cubed. Okay. And then the second step is for us to identify the terms above. So the first one is distinct linear factor, which gives us a all over x. And then the other term here is repeated linear factor, because this one is raised to the power of 3. So I'm not going to circle it kay basin maglibog mo that I'm circling na ay mga circles mga 1, 2, 3. Okay, so since this one is repeated, so starting off with b, so b all over x plus 1. So again, up until we reach the nth power, so c all over x plus 1 squared. Then lastly is your last term, that will be x plus 1 cubed, then d. So earlier we just solved 2 equations. So this time we're going to solve 4 unknowns here, a, b, c, and d. Okay? So this becomes our partial fraction decomposition. Okay, so next step is, okay, sorry. Okay, so for the third step is we're going to solve the partial fraction. So I didn't put the words here, but you can refer the words from the previous example. So again, writing the equation, the original equation on the left side. So x times x plus 1 cubed. Okay. And the right side is your partial fraction decomposition. So a over x plus b all over x plus 1 plus c all over x plus 1 squared plus d all over x plus 1 cubed. Okay. So next step is multiplying everything by the denominator on the left side of the equation. So that's x times x plus 1 cubed. Okay, so the left side becomes x cubed minus 1 is equal to a So since it's over x, so what remains on the factor is x plus 1 cubed. Okay. Then the second term is b times x plus 1 squared. Then plus c times x plus 1. Then lastly is your d, which is multiplied by x term only. So that's how you create the single line, or by eliminating the fractions. So if we're going to try to solve it by elimination, so 3.1. So if you're going to observe the equation, so let's say you want to eliminate a. So at x is equal to negative 1, so this becomes negative 1 cubed minus 1. Then a times negative 1 plus 1 cubed, so this becomes 0. So b x then times negative 1 negative 1 plus 1 excuse. Okay, so negative 1 sorry, so this is also negative 1 here. So negative 1 plus 1 squared, so this is 0 also, plus c times negative 1 plus 1, this is also 0, then plus d times negative 1. So we have negative 1 minus 1 is equal to negative d. So d is equal to 2, diba? So how about the others? If we try to eliminate the other terms, so I think it's really impossible, diba? Because so we have solved d, but how about for a, b, c, and a, b, and c? So looking at your equation, so the only possible x values for elimination is only x equals negative 1 and x equals 0. So if we let x be equal to 0, so we can solve a, diba? Because we can eliminate b, we can eliminate c, we can eliminate d. So we can solve a, but how can we solve for b and c? So again, that's the downside of the method of elimination. So it's only good for two unknowns. So we cannot solve b and c here. Okay, so again, the only possible values for x for elimination is only x equals negative 1 and x equals 0. So x equals negative 1, we can, so again, if we try to identify the constants that can eliminate x equals negative 1, so we have a, b, and c, diba? So if x equals 0, so we can eliminate b, c, and d. So there's no other possible way to solve b and c here. Okay, so going to the other method, which is equating coefficients. So I think that's the best method for me. So even though it's just two unknowns, so I'm going to use equating coefficients. Okay, so we have x cubed minus 1. Then we have a times x plus 1 cubed plus b times x, then x plus 1 squared, plus c times x plus 1, then plus x. Okay. So next step is we're going to expand. So expand, then expand the cube, then expand this one, then multiply this one, then multiply, diba? So we're going to have, so I think it's easy to expand cube here. So by formula, this one is x cubed plus 3x squared plus 3x plus 1. So shortcut in algebra. So I think perfect cube, diba? Perfect cube. Then this one is bx times x squared plus 2x plus 1. And this one is c times x squared plus x plus dx. So simplifying further is we have ax cubed plus 3ax squared plus 3ax plus 3a. Okay. Next term is b. So we have bx times x squared, that's bx cubed plus 2bx squared plus bx. Then plus cx squared plus cx, and lastly is your dx. So next is you're going to equate the coefficients or group together the same terms first, di. So grouping them together is, so the cube first, cube. So I think there's no other cube term here. So in shortcut, this one becomes a plus b x cubed. Okay. So next are the squared terms. So 3ax squared, and then 2bx squared, and then cx squared here. So plus 3a plus 2b plus c, and then x squared. Okay, so next are the x terms. So 3ax, bx, cx, and then dx. So you have 3a plus b plus c, then plus d times x. Then lastly is your constant term here. So plus 3a alone. Okay, so equating coefficients. So starting off with x cubed. So the coefficient of the x cubed on the left side is 1. Then on the right side, that's a plus b. Okay. So next is x squared. So since on the left side, so here, left side, so since there's no x squared term, so the left side is 0. The right side is 3a plus 2b plus c. So next is the x term. So x term is still 0 on the left side. And the right side is 3a plus b plus c plus d. And then the constant term is negative 1, because we have negative 1 on the left side, equals 3a. So sakto ba ni? Okay, so I think this one is only a there. So this one is a only. A and then a. So a siya because a times 1 there. Okay, so notice we have 4 equations. So 1, 2, 3, and then 4 equations. So which is also valid because in algebra, so to solve 4 unknowns, we need 4 equations. So looking at equation number 4, so we have already an answer here. A is equal to -1. So looking at the other equations, so we can use equation number 1. So equation number 1, so we have 1 equals A plus B. So we have 1 equals -1 plus B. So B is equal to 2. Okay, so next is using equation number 2 to solve for C. So 0 is equal to 3 times -1 plus 2 times 2 plus C. So that will be C is equal to -1. So ako lang i-shortcut because there's no space already for us to solve the integral. So equation number 3, so that will be 0 is equal to 3 times -1 plus 2 plus -1 plus D. So D is equal to 2. Okay. So D2. Okay. So diba, I think the long process here is to solve the partial fraction before integration. So giving us the new integral is we have -1 all over x, then plus 2 all over x plus 1, then minus 1 all over x plus 1 squared, then plus 2 all over x plus 1 cubed dx. Okay. So this one is -ln. So again, if we try to integrate this one individually, so I'll just use the shortcut version lang. So u is equal to x, and then du is equal to dx. So this becomes negative du over u. So on this one is let u be equal to x plus 1. So du is still dx. So since this one is applicable to the other terms, diba? So this becomes 2 integral of du over u. This one is negative integral of du over u squared, which can be represented also by u to the power of -2 du. So this one is plus 2, then integral of du all over u cubed, or this one is plus 2 all over u to the power of -3 du. Okay, so solving the equation is you have negative ln u. So that's x, then plus 2 ln of x plus 1. So this one, the integral of this one is -1. So u, so this one is x plus 1 raised to -1 all over -1, then plus 2, so times x plus 1 to the power of -2 all over -2 plus c. Okay, so cancel out 2, then this one becomes positive, this one becomes negative. So you can also revert the negative sign in the denominator. So the final answer is negative ln x plus 2 ln x plus 1. then plus, so 1 over x plus 1, then minus 1 over x plus 1 squared plus c. So this is the final answer. So notice nga super taas na kayo, no? So that's how you solve your partial fractions. So questions so far? So medyo libog din siya, no? So questions or clarifications? So maragwa na question, no? Kay libog na. Basta yung dyan naminaw gani kay lisod na kay i-comprehend, no? So sige lang, just try to review the recording later, step by step. Okay, so let's go to the final example. So again, upon observation of the denominator, so this one can be factored out. So this becomes x times x squared plus 2x plus 5x. So notice that the denominator cannot be solved. The quadratic equation cannot be further factored out because the middle term is 2x. I don't know how much is 5x, so this one is only 5. So notice that the middle term is 2, and then the constant term is 5. So the factors for 5 is only 5 and 1. So the middle term should be 6x for us to factor this one completely. So next step is, since we have a distinct linear factor here, this one is distinct quadratic factor. So this gives us x all over a, then plus the a over x. So this one is a over x for the distinct linear factor, then plus the distinct quadratic factor, which is bx plus c all over x squared plus 2x plus 5. Okay, so our equation becomes, so again writing the original equation, x squared plus 4x plus 10 all over x cubed plus 2x squared plus 5x equals the partial fraction decomposition, a over x plus bx plus c all over x squared plus 2x plus 5. Okay, so multiplying everything with the denominator on the left side of the equation, so that will be x cubed plus 2x squared plus 5x. Or if you want to multiply the factored terms, so it could also be x times x squared plus 2x plus 5. So we now have x squared plus 4x plus 10 is equal to a times x squared plus 2x plus 5, then bx plus c, then times x. Okay. So since we have three unknowns, so again, it's best that we go immediately to the equating coefficients part. So we go to 3.2. So expanding, so this becomes ax squared plus 2ax plus 5a plus bx squared plus cx. Okay, so grouping together the x squared first. So that will be a plus b times x squared. So next are your x terms. So you have 2a so 2a plus c times x. And then lastly is your constant term. So 5a. Okay. So starting off with the x squared term. So we have 1 on the left side of the equation. It's 1 here. Against the coefficient of x squared on the right side, that would be a plus b. So next is the coefficient of x on the left side, that will be 4. Then the right side is 2a plus c. Then lastly is the constant. So you have 10 is equal to 5a. So again, it is valid because we have three unknowns and we have three equations. So starting off with equation number 3. So 10 is equal to 5a. So a is equal to 2. Okay, so you can either use equation 1 or 2 to solve for your b and c parameters. So equation number 1. So we have 1 is equal to 2 plus b. So b is equal to negative 1. And then using equation 2, so that's 4 is equal to 2 times 2 plus c. So c is equal to 0. Okay. So the final format of your integral will be the integral of, so starting off with a, that's 2 all over x. And then plus, so that's bx plus c. So we have negative 1 as your b, so that will be negative 1 times x. Then our c is 0. So that will be x squared plus 2x plus 5 dx. Okay, so this becomes the integral of 2 over x. Then instead of plus, this becomes minus. So minus x all over x squared plus 2x plus 5 dx. Okay, so this one is, I think, we can now solve the integral. So this one is simply let u is equal to x, let u be equal to dx, du I mean. Then the integral becomes 2 integral of du over u, which gives us 2 ln u plus c, di ba? So the right side is how are we going to solve this one? So saan mo siya pag-solve ron? But so I think this one is an advanced technique also. So if you want to use partial fraction again, because x to the power of 1 against x to the power of 2, so you can use partial fraction again. But if you want to solve this one in shortcut method, so you can use completing the square. So this becomes x squared plus 2x plus 1, then plus 4, di ba? Because 1 plus 4 is also equal to 5. Okay, so this becomes x plus 1 squared plus 4. So the equation becomes x all over x plus 1 squared plus 4. So mahana siya, di ba? Okay, so let u be equal to x plus 1. So since we have x in the numerator, so this becomes u minus 1 is equal to x. Then the derivative is du is equal to dx. So this becomes u minus 1 all over u squared plus 4. Okay, then du. So since the numerator is in two terms, so you can now separate the terms. So u over u squared plus 4 minus 1 all over u squared plus 4, then du. Okay? So taas kayo, no? So the right side, the minus 1 over u squared plus 4, so this one is automatically 1 over a arc tangent u over a. But for the left side is, if you're going to let this one be equal to z lang, z equals to u squared plus 4, then dz is equal to 2u du, then dz is equal to dz over 2 is equal to u du. So the equation becomes dz over 2 all over u, di ba? Or this becomes 1/2 integral of dz over, z di siya u di, z. So basta i-follow lang din siya later. Okay, I think I'm going too fast na. So my tip here is once you reach this term here, so just separately integrate the terms lang. So marag hugaw lang pagka-present ako ang right side, kaning siyang integral dire. Okay, so this is negative, 1/2 ln of z, diba? Or this is equal to 1/2 ln of u squared plus 4. So the final answer for this one, so starting off with this term here, 2 ln u. So 2 ln u, which is x, okay? And then minus, so don't forget the minus sign here. So nawa lang minus sign, but apa na siya minus sign dire. Minus sign dire. So minus 1/2 of ln of u squared plus 4. So this is x squared plus 2x plus 5. So ano nga naman siya because u squared plus 4 is x plus 1 squared plus 4. And then ako lang expand. Okay? Then lastly is plus because minus times minus. So 1 over a, that will be 1/2. And then arc tangent. So u squared is x plus 1. So x plus 1 all over 2 plus c. So this is the final answer. So medyo gubot siya tanahon, but just try to separately integrate the two terms here. So integrate this one first, then integrate the other term separately. So again, what I did here is completing the square. So ano mo siyang x plus 1 squared plus 4. Or I just borrowed 1 from 5, that's why it became x squared plus 2x. So getting 1 from 5 to complete the square. Then plus 4, di ba? Because 1 plus 4 is still 5 here. Okay, so I think that's for number 3. So do you have questions, further questions? Okay, so if you don't have questions, so I think that's it for today. So see you all next meeting for the last topic, which is definite integral. So it will be just a short discussion because definite integral is easy to discuss because what's new in the definite integral is just applying the limits of integration.